Pop quiz. What cools you down fastest? Standing still, a fan blowing on wet skin, or the sun on wet skin? Hold that thought. We'll reveal the answer in a minute. In this video, you learn what evaporation is, what's happening at the molecular level, and why it can cool things down, from your skin to water in an earthen pot. Let's start with something familiar. You've seen evaporation when a puddle slowly disappears. The liquid doesn't vanish. It turns into a gas and mixes with the air. That change from liquid to gas is evaporation. Here's an important detail you shouldn't miss. Evaporation doesn't require boiling. It can happen at any temperature below the boiling point. Warmer usually means faster evaporation, but even cool water can evaporate, just more slowly. Now let's zoom in. Inside liquid water, molecules are always moving, bumping around at different speeds. Some are slow, some are fast. The temperature of the water is basically a measure of average motion, how much kinetic energy the molecules have on average. So what happens at the surface? Near the surface, water molecules collide with air molecules and with each other. Sometimes a surface molecule gets enough energy to break free from intermolecular forces holding it in the liquid, and it escapes into the air as water vapor. Here's the key idea. The molecules that escape are usually the ones with the most energy, so evaporation tends to remove the fastest, highest energy molecules first. Think of it like averaging numbers. If you remove the highest value, the average drops. In the same way, if the highest energy molecules leave the liquid, the average kinetic energy of the remaining molecules decreases. Lower average energy means lower temperature. So evaporation doesn't just change liquid into gas, it can cool the remaining liquid because the most energetic molecules are the ones leaving. Now let's return to the pop quiz. The fastest cooling happens with a fan blowing on wet skin. The moving air helps carry away water vapor, so more high-energy molecules can keep escaping. More evaporation means more cooling. This is exactly how sweat cools your body. Sweat spreads as a thin film on your skin. To evaporate, it needs energy, and it pulls that energy as heat from your skin. So your skin temperature drops, and you feel cooler. And notice something important. The fan doesn't magically make cold. It speeds up evaporation. No evaporation, no big cooling effect. Air matters too. In dry air, evaporation happens easily. In humid air, the air is already crowded with water vapor, so evaporation slows down and sweating feels less effective. Ready to lock it in? Tap the link for study guides and flashcards on this topic, so you can keep learning without missing a beat. Now let's connect this idea to clay pots. Clay is porous, meaning it has tiny pathways that let a small amount of water seep toward the outer surface. That seeped water forms a thin film on the outside. When that film evaporates, it steals heat from the pot and the water inside, so the remaining water becomes cooler. Compare it to a glass bottle. Glass isn't porous, so it can't create that outer film. Less evaporation from the container's surface means less cooling. A similar trick is wrapping a bottle in a wet cloth. The cloth holds a thin layer of water with lots of surface area. As it evaporates, it cools the bottle, especially if air is moving. Now let's clear up a common misconception. Evaporation does not require boiling. Boiling happens throughout the liquid at a specific temperature called the boiling point. Evaporation, on the other hand, happens only at the surface and can occur at any temperature below the boiling point. Here's the whole process in 3 steps. First, the fastest molecules escape. Next, the average energy of the remaining liquid drops. Therefore, the temperature drops, and you get a cooling effect. To recap, evaporation is liquid turning into gas at the surface. The highest energy molecules tend to leave first, so the average kinetic energy drops. That's why sweat cools your skin, and clay pots can keep water cooler. Ready to quiz yourself with the content covered in this video? Check out the link in the description, where you'll find Quizlet content made just for you.